AMC 8, question 7. A rectangle with sides parallel to the x-axis and y-axis has opposite vertices located at 15, 3, which is this point. 15, x is 15, y is 3. And 16, 5, which is this point. X is 16 and y is 5. A line is drawn through points A00 to B31. Another line is drawn through points C010 and D29. How many points on the rectangle lie on at least one of those two lines? So this question firstly does involve a very advanced math concept, which is analytical geometry. Where you have x-axis, every point has a x coordinate, and similarly y-axis, you have a y coordinate. You can express a line using an equation, and then you can use the line equation to solve for some really complex things. However, this question has two solutions or two ways to solve for it. The first one doesn't really need this fairly advanced analytical geometry knowledge and doesn't really involve solving complex equations. I'm still going to go through the harder, the more standard way to solve a analytical geometry question. But I want to start from option 1 first, which is a lot more intuitive. So I really like this question because building on your intuition, you can probably solve it pretty quick. So I'm going to start from option 1, which is draw the line. So what do I mean here? First thing, I want to go to the geometry questions and give you some hint. One of them is, in general, when you have AMC type of questions, the picture may not be really drawn in scale. That is because if it's a really hard geometry question and they don't want to give out the answer by just having you measure it or estimate it, so usually the picture is not in scale, and I don't recommend solving a geometry question for AMC by estimating it through drawing a line or something. But when there are coordinates, you can just try to draw things up. That is because when you have coordinates, things are very accurate. So remember this. With coordinates, you can try to draw the line. In general, I don't recommend it, but if you have coordinates, you can give it a try. For example, let's look at line AB. Line AB starts from 0, 0, where x is 0, y is 0, and goes to 3, 1. When you try to draw this line, how do you do it? Like, how do you extend this line without missing the accuracy? Well, you probably noticed going from A to B, you increase x by 3 and you increase y by 1. Because x changed from 0 to 3, y changed from 0 to 1. So if I continue from B and move on, what would be the next point I know is on this line? Well, I would say increase x by 3 again, increase y by 1 again. You'll probably be here. Not probably, you will be here, which is going to be 6, 2. And you can continue on. The next point, 9, 3. Because you have coordinates, you are able to make sure the picture is fairly accurate. So continue on, you will get to 12.4. And then you are going to meet this point, which happens to be one of the vertices for the rectangle. And this point is 15, 5, which makes sense because those 4 points are going to be 15, 5, 53, same axis for x, and 16, 5, 15, 5, same y, and the last point is going to be 16, 3. So that's the first line. It has 1 point that is on the rectangle. Same thing, C to D goes from 0 to 10 to, and then 2, 9. So how does the line work? Increase x by 2, reduce y by 1. Continue on. The next point is going to be increase x by 2, 4, 8. And then 6, 7. And then 8, 6. Continue on. Then here, here. So that's interesting. This line actually misses the rectangle. There's no point that is on this line, which is also on the rectangle. So the answer for this question is B, 1. You can actually stop now, stop watching now, because I'm done with option 1, and I think this is actually the methodology I would recommend. But I'm going to use the next few minutes to go a little bit deeper into analytical geometry. I would see that's an optional content, but given that this is touching this, so I do want to talk about option 2, which is you actually try to find out the equation of the line. So option 2. Option 2 is get the equation. And I want to see, I'll try to use an intuitive to explain how equation works. And you actually already get some part of it. Here's the example. For line AB, if you remember, we increase x by 3. So x goes up by 3, and y goes up by 1. And you do find this is always true. This relationship holds true as we extend the line. This is actually defining a slope for this line. Slope, as the name recommends, is actually about how much do you increase y by divided by how much you increase x by. So in this case, it's 1 over 3. Slope equal to 1 over 3 means every time x increases by 3, y increases by 1. And vice versa, x decreases by 3, y will decrease by 1. And with that, you can write out the equation for this line AB as y equal to a third of x plus something. How do you find this plus something? So how do you find the something? You can put in any coordinate of any point on this line to find it. For example, I know 0, 0 is on this line, so put 0, 0 in. You can find y equal to 1 over 3 x plus b. 0, 0 means 0 equal to 0 plus b. So b is actually equal to 0. This line is 1 over 3x. So you are able to find out the equation for line AB. And then, you can just quickly draw a line. But this time I actually don't need you to draw it super accurately, because what I'm going to do is going to say, okay, when x equal to 15, what is my y? Because I want to know when this line passes 15, which is where the rectangle starts to show up, What is my y value? Well, you let x be 15, you'll find y equal to 5. So you know this line will pass 15, 5. So same conclusion. I can just draw a very scrappy line, but from the equation, I know this line passes 15, 5. And similarly for CD, CD is x increased by 2, y decreased by 1. So what would be the slope? You probably get it. In this case, the slope is actually negative because you increase x by 2, y decrease by 1. So this is negative 1 over 2. And in that sense, very similar methodology. Y will be equal to negative 1 over 2x plus something. Let's call it C this time. You actually just use B if you want as well. Similarly, put 0, 10 into this equation. And you can find, you get 10 equal to C. So the equation of the line is y equal to minus 1 over 2x plus 10. And very similar, you put in 15. So x equal to 15, y is equal to minus 7.5 plus 10, so it's 2.5. Which means 15, 2.5 is on this line. So similarly, I have 15 and I have 2.5. So same conclusion. I know when this line is extended, it will miss the rectangle. So both methods work. And I actually personally like option 1 better.